Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. I'm Dr. Muhammad Majid, and today our topic is Coulomb's law. That is on page number 4 and article number is 11.1. इससे पहले लेक्चर में हमने पढ़ा था that a force exists between two charges. That force may be attractive or may be repulsive. अगर same charges है then this force is repulsive. अगर opposite charges है, one is positive, the other is negative, then this force is attractive. So magnitude of जो force between the charges और चार्जेस के दरमियान डिस्टेंस क्या है, तो उसके लिए एक रिलेशनशिप जो मैथमेटिकल रिलेशनशिप था डेट वाज गिवन बाय द कूलम्स एंड in 1785. Remember, so Coulomb's law is basically the quantitative description of electrostatic force that exists between 2 point charges. Statement Coulomb's law का जो है for time सेविंग ऑफ स्टेटमेंट बुक से भी देख सकते हैं, लेकिन स्टेटमेंट क्या था? स्टेटमेंट लाइक फॉर एग्जांपल यू हैव टू चार्जेस, वन इज Q1 and the other is Q2. Let the distance between the two charges is R. Then let's if it is the same charges, अगर same charges है the force is repulsive, अगर opposite charges है the force is attractive. So Coulomb's ने different experiment किए थे in order to calculate the magnitude of this force, और जो apparatus Coulomb's ने use किया था that was known as the torsion balance, remember, और experimentally he observed that जो force of attraction है और repulsion है between 2 point charges, that force is directly proportional to the product of magnitude of charges. That is, Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of magnitude of charges and inversely proportional to the square of the distance between the charges. अगर फॉर एग्जांपल दो चार्जेस के दरमियान जो डिस्टेंस है डेट इज r, तो कूलम्स लॉ के मुताबिक ये जो फोर्स है डेट इज इनवर्सली प्रोपोर्शनल टू द स्क्वायर ऑफ द डिस्टेंस बिटवीन द चार्जेस, and that's why I remember the Coulomb's law is known as the Coulomb's inverse square law. If you combine these two equations, combining equation 1 and 2, combining 1 and 2, we get magnitude of force जो है that is directly proportional to the Q1, Q2, that is the product of magnitude of charges, inverse square with the distance. So you know, if you remove this sign, we have to put is equal to constant, and then Q1, Q2 divided by R square, and here this constant of proportionality it is Q1 Q2 divided by R square, where this K is constant of proportionality and it depends, इस K की जो वैल्यू है it depends on the system of unit, आप कौन सा यूनिट इस्तेमाल करें सिस्टम, and it also depends on the medium between the charges. For example, if the charges are in vacuum or if you place some medium that is insulator or any other medium between the charges, then you know ये जो force होगा फिर ये change होगा. So ये जो force it depends on this constant K, और constant K जो है it depends on the system of unit and also on the medium between the charges. So generally remember the Coulomb's law is only applicable to the point charges. Point charges mean the localized, something localized charges. आपके पास जो distance है between the charges is must be greater than the size of the charge, and again dear student remember Coulomb's law जो applicable है for the point charges means stationary point charges. We are studying electrostatic, and again ये जो charges जो होंगे, it must be something like spherical distribution. Coulomb's law, आप जो arbitrary charges है, you cannot apply the Coulomb law to that case. And also अगर आपके पास irregular distribution है, then the situation again is going toward the complex side. So F is equal to K Q1 Q2 divided by R square. This Coulomb's law is analogous with the Newton law of universal gravitation. That was for the masses, if you remember, and that was F is equal to G m1 m2 divided by R square. Again, this is Newton law of universal gravitation, that is inverse square law. But this force is always attractive, and this force may be attractive or it may be repulsive. So that is the Coulomb's law. Next, Coulomb's law in vector form. Coulomb's law in vector form. Force is a vector quantity. You know, quantities are of two types. One is scalar, the other is vector. Scalars are described by the magnitude. Magnitude means a number with a specific unit, and vectors are those having magnitude and direction. So force, you know, force is a vector quantity. So you can write the Coulomb's law in vector form very simple. For example, you have two charges Q1, Q2, and let if you consider the force, for example, F12 is a force exerted on charge Q1 due to charge Q2, then we can write this force in the vector form as K Q1 Q2 divided by R square. R is the distance between the two charges, and that is the magnitude. So for vector we need direction, और direction आपको पता है, we use the unit vector. So R12 is the unit vector which gives the direction of the force. F12, this is in the direction of R12, because simply you know this thing. Simply you know this thing, कोई भी वेक्टर हो तो किसी भी वेक्टर को आप मैग्नीट्यूड और आप उसके साथ लिखते हैं यूनिट वेक्टर. So one is the magnitude, the other is unit vector. This is the magnitude and this is the unit vector R12. Let this is equation A. Similarly, this is F12 is the force exerted on charge Q1 due to Q2. Similarly, a force is exerted on charge Q2 due to Q1. So the next thing is F21. This is another force on charge Q2 that can be written as K Q1 Q2 divided by R square into R21 unit vector. Clear? So one is this direction, the other is in this direction. So remember, ये जो force होगा, that is along the line joining the two charges. So the two unit vectors, this is equation B. R12 is unit vector having magnitude 1. It only gives you the direction. So this is unit vector, this is unit vector. Both have equal magnitude, means of unity, one magnitude. So remember this R12 ये जो unit vector है, that are both magnitude wise, these two are equal, but only if one force is in this direction, the other force is in this direction. So only the change of direction is there, because unit vector gives you the direction. So if R12 equal to R21, that is only equal if there is negative sign. Magnitude wise these are equal, remember, both are unit vector. The negative sign shows you the direction, both have the opposite direction. So if you put this value R12 equal to minus R21 here in this equation A, then what we get, put in equation A. So equation A implies that F12 this is equal to K Q1 Q2 divided by R square to minus R21. Minus R21. This is the unit vector, remember. So just put this value, what we get, F12 is equal to minus K Q1 Q2 divided by R square into R21. By equation B, this KQ1 Q2 divided by R square into R21, this is equal to F21. So this is basically F21. So I can write it as minus F21. So what does this equation shows? This is the action force and this is the reaction force. The F12 is the force exerted on one charge and that is the reaction, which is the force exerted on the other charge. So that basically gives you the Newton's third law. Action and reaction are equal in magnitude but opposite in direction. So one is the action force and the other is the reaction force. So next, in our next lecture, we will study the detail about this constant K. कांस्टेंट के की वैल्यू क्या है, कांस्टेंट के किस चीज़ पे डिपेंड करता है, एंड हाउ Coulomb's law changes if you put some material medium between the charges. So that is for today. You study it, and in next class we will study the Coulomb's law in material medium and what would be the value of K, किन चीज़ों पे डिपेंड करेगा. So then we will study it in the next lecture. So that is for today. Okay, thank you.